Hey guys, I wanted to do another quick review. Some of you guys did great on the quiz. A few of you need to take it again. So I wanted to go over one more time, just a quick little mini review on the distance formula and the midpoint formula. Guys, on the distance and midpoint formulas that I put on the quiz, I just took the words straight from the book. So the distance formula, just to kind of reiterate, we are actually, and what we're looking at for the distance formula is we are taking, if we have a quadrant here and we have 2 points on the quadrant anywhere, a line segment, the distance formula is simply finding the distance from this point to this point. That's all that we're going to be doing. That's all that the distance formula is doing. It's just saying if we have 2 points plotted anywhere on a quadrant, we are asking what is the difference between those 2 points? And the way that we do that is we just use a formula that's given to us, which is the distance, that's the D stands for distance. That's going to give us the square root of the second x coordinate minus the first x coordinate. We're going to square that plus, I didn't write this over far enough. Do it down here where I have more space. That's going to give us the second x coordinate minus the first x coordinate, square that. Then we're going to add the y coordinates, and that's going to be the second y coordinate minus the first y coordinate, and we're going to square that. Okay, so I had a conference today with a student, and they were thinking that these subscripts meant that you squared that number. You're not. This is just telling you that for these different points that we're taking, if we have a point M and N, we are taking, remember our coordinates are, we can just use what they have in the book. So 6 and 3 and 5 and 7. This is our first x coordinate and this is our y coordinate. We just chose this arbitrarily. Then this is our second x coordinate and this is our second y coordinate, okay? What I mean is we just chose M to be our first point and we just chose N to be our second point. We could also switch these, but it matters down here because we want to take our second coordinate and subtract it from our first coordinate, and we want to take our second coordinate, our second y coordinate, and subtract it from our first coordinate. So we're wanting to keep these in order, okay? So here, all we're going to do is we're going to put in these points down here in this equation. So our first point we have called 6 and 3 for M. And then our second one, our second coordinate is going to be 5 and 7. So this formula is asking what is the second x coordinate, which we said here is going to be 5. So we're going to have 5 minus 6. We're going to square that. And we're going to add the second y coordinate, which is 7, minus our first one, which is 3. And then we would square that. Now remember here, we're using orders of operation, okay? So we're going to go in here into our parentheses first. Parentheses are also known as a grouping. Think of gems, that's a grouping. So we're gonna do this first. We're gonna say 5 minus 6 is -1. That is still squared because that was squared in our formula. Plus 7 minus 3, we're gonna then do this grouping. That's gonna give us 4, and we're gonna still square that. This is all the square root still. That is going to give us 1 plus 16. When we then do our next is in our next order of operations, that is exponents. Remember, gems is grouping, exponents, multiplication, division, and then subtraction and addition. Okay, so now we've figured out our exponents. It's still the square root, and that's going to be the square root of 17. So that means the square root of 17. Hey, Alexa, what's the square root of 17?
The square root of 17 is 4.1231.
4.1231. So this, you can just leave it in a square root. You can leave this in a square root, or you can say that the square root of 17 is approximately 4.1231. So you would know that this point from this point, given these coordinates, is approximately 4.1231 units away from each other, or the square root of 17. Okay? So that is all the distance formula is. Okay. Next, we have the midpoint formula. And again, look at the wording of the midpoint formula. That was one of the questions. I just took the definition. The midpoint formula is the same thing as the distance, but we're only looking at it halfway. So basically, the midpoint is going to be the point on a quadrant. If we have 2 points, we are taking a new point. We are finding the halfway point. That's the midpoint. So it makes sense if you would take this chord. So let's say this first point is M and the second point is N. You would take the average basically of those two, right? You're going to take your X coordinates and then you're going to divide those by 2. Then you're going to take your Y coordinates and divide those by 2, because that would be halfway. If we're finding halfway of something, think about what it's asking: midpoint, halfway. That's why you would actually take those 2 points and divide it by 2. Okay. So, for instance, on the midpoint, if we are given the point 3 and 8 is one of the endpoints, and -9 and -4. These are the 2 points that are on a line. Okay, so if we graph these on a line, we're going to say the 0.38 is going to be 3, and then we're going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be this first point. And then the other one is -9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then down 4, 1, 2, 3, 4. So that would be all the way over here. So we're finding the point somewhere. Oops, I did not do that very well to scale. We're trying to find the point that is midway between these 2 points. This is 3 and 8, and this is -9 and -4. Okay? So the midpoint is actually what we're looking for is going to be 2 new coordinates. We're finding the point, the place. We're looking for 2 coordinates there. That is the difference, that is the distance between these 2 points. That's what the midpoint is, okay? So our midpoint formula, we are given it algebraically, is again taking our X coordinate. Again, this is a subscript. It doesn't mean that we're squaring the term. We're dividing it by 2 to find our new X coordinate. And then we're taking, this is going to be a comma here. We're not adding these together. Again, we're trying to find the new point. And then we're going to take Y plus Y2, square it for our new Y coordinate of the midpoint. So in that case, when we have 3 and 8 as one point, and -9 and -4 for our other point, we are just going to put this in. Again, remember this. This is our X1, this is our Y1, this is our X2, this is our Y2. This is in the coordinates. Remember, it's alphabetical. Your X always comes first, and then your Y. So this is your X coordinate, this is your Y coordinate. This is your second X coordinate, and this is your Y and your second Y coordinate, okay? So now we're just going to fill this in. So X1 is 3 plus -9 over 2. That's going to give us our first point. And the other one is going to be Y1, which is 8, plus our second Y is -4 over 2. That's going to give us our second point for the midpoint, our y-coordinate. So that is going to give us 3 plus negative 9 is negative 6 over 2. And then for our second one, it's going to give us 4 over 2. Negative 6 divided by 2 is going to give us a negative 3. And then 4 divided by 2 is going to give us a 2. So our new coordinates for the midpoint is going to be negative 3 and negative 2. That means if we graphed 3 and 8, just like we had done a few minutes ago, and 9 and 4, our halfway point would be at negative 3 and 2. Okay? That's all that the midpoint formula is telling us. Okay? For the other thing that I did for the quiz was I just took the definition. I just took the wording. So the coordinates of the midpoint of a segment are the average of the endpoints x coordinates, these, and the average of the y coordinates. Okay? So use your book, guys. Use your book to help you with the quiz. Feel free to do that. That's a better way to help you learn. When we're not face-to-face learning, use your book. Use that as a source. A lot of you guys were finished in 10 minutes. 15 minutes was the average for this quiz. Use your time. Go through your answers and check it. Okay? The answer will be there in the quiz if it's multiple choice. Okay, so I just wanted to go over that. I wanted to go over also, it's always good when I have a conference with a student. They can kind of show me areas that you guys might not be completely, you might kind of be lost on. So this student also was not really straight on the angles. Some of you might have the same thought. So on the angle, let me see what page that was on. I think this is an important point to make sure that you understand as we go forward in trigonometric ratios. When we are finding the sum of the angles in a triangle, all of those angles in a triangle, any triangle, if we're having a right triangle, whatever, all of these 3 angles in a triangle are going to equal 180 degrees. Okay? You can add all of these up and they're going to equal 180. Okay? Always. Okay? So that's the first thing that you need to make sure you understand. Secondly, we can classify angles by the angle measures. So that means if we have a triangle, and we have one triangle that is a 90 degree angle, we know that this is a right triangle. Okay? A right triangle will only have one 90 degree angle, because if we know that all triangles equal 180 and we have one that's 90 already, we can't have 2 that are 90 because we wouldn't be able to have enough area or enough degrees for a third angle. Okay? So a 90 degree angle is always a right triangle. Okay? So this is going by the measure an angle, measure of a triangle by angles. Okay, so one way we can do that, a measurement is a right triangle. This is on the inside of this angle, okay? Another way we can look at it is an acute angle. So this would be, for instance, if you have a 60 degree angle here, a 75 degree angle here, and a 45 degree angle. These are all on the inside of the triangle there. These, an acute triangle means that they have 3 angles that are less than 60 degrees, 90 degrees, sorry, that are less than 90 degrees. Okay? That's another way we can measure angles or triangles by their angle. Okay? And then we have 2 other ones. So we have a right and we have an acute. We can also measure it by an obtuse angle. That means one angle is greater than 90. In the book, they give you one that's like this. So this one is 105. This one is 35. And this one is 40. Okay? So I can't really see that's 40. 40. Okay? So in an obtuse angle, we're measuring a triangle given its angle. We can call this obtuse because one of these, one angle, is greater than 90. And we can only have one that's greater than 90 because if we had another one that was greater than 90, we wouldn't have enough degrees to make our third triangle over our third angle. Okay, so obtuse angle means only one is greater than 90 because we know that all of these angles have to figure out to be 180. Okay, and then finally, another way we can do it is one special instance called an equiangular triangle. Again, this is looking at the angles of a triangle, and this would be a 60 degree, a 60 degree, and a 60 degree. That means all of these angles are 60 degrees. They're all the same, and this all 60, 60, and 60 all equals 180. Okay? So if you look at all of those examples that they give you on 462, 60, 45, and 75, that's for the acute, that still equals 180. A 55, 35, and 90, that still equals 180 for your right triangle. An obtuse, the 40 degree, 105, and 35, that still equals 180. And the equiangular, 60, 60, and 60, all of those equal one angle, but 180. So this is the way that we are defining or measuring our triangle given the angles, okay? So we're just looking at the angles. The other way we can measure triangles, which is where this other student got a little bit confused. So this is by the angles. We can also measure the triangle by its side lengths. So in this way, we're not looking at the angles, but we're looking at the lengths of the triangle. Okay, so the lengths of the three sides. We're looking at this length, and this length, and we can actually measure or name our triangles depending on the lengths of of these sides. Okay, so one was by angle, one was by lengths, and if we look at the lengths, then we have three ways we can classify triangles. The first is called an equilateral, and that is when all five lengths are the same. This is 5 centimeters, it could be 10 centimeters, it could be whatever, but all five lengths are the same. This is 5, this is 5, and this is 5. All three of those are the same. They are equilateral. Okay? So that's one way. Another way is called an isosceles. And that is when you have two sides, two lengths that are the same. So here we have a 6 foot and a 6 foot. These are our two that are congruent or equal. That word means the same thing, congruent and equal. And then this one down here is different. This one's 9 foot. So we have two equal sides. Or you can say two congruent, same thing. I'm running out of room. Two congruent sides. Okay? That's an isosceles triangle. Again, we are defining the angle by the sides, the side lengths. Okay? And then the last one, if we have two that are the same, three that are the same, then we can also have a scalene triangle. And that is when you have no congruent side lengths. Or no sides are equal. Same thing. Okay? So that would be one where you have like this is 5 millimeters, this one is 4 millimeters, and this one is 3 millimeters. So 5, 4, and 3. No sides are equal. Okay? So I wanted to go over that. The side lengths are going to be important as we get into tangent, cosine, and sine, which you're learning about now. So I wanted to go back and make sure that you guys understood that really quickly. If this student was having problems, some of you, you don't even need this. You've already got it. But this is just to help some of you guys that didn't do quite as well on the quiz before you try to retake it. So guys, listen, I am here. If you have a question, jump on Google Chats or send me a text or an email, and I can meet with you individually. It's not a problem. We can have a Google Meet. I know you guys have different classes that you're taking and you have different expectations from different teachers, but I'm here. So 1 to 3 is really my time. I can meet you at other times. If 1 to 3 doesn't work for you, we can do another time. But always from 1 to 3, I make sure that I'm right here for you guys. So I wanted to give you this video to help, and I hope it does. This was some of the questions that another student had, so I thought I would make a quick video to help you guys, and I hope it does help. One other thing I wanted to go over, I guess, real quick. Just the sides of a triangle. He had this one too. So if we have a 90-degree angle, we call this our hypotenuse. That is always opposite a 90-degree angle. Okay, that is the hypotenuse. And the other are sides. Okay, so the hypotenuse in a right triangle is always the side opposite. Okay, at least for a 90-degree angle. That's what you need to know for right now. So we'll leave it there. But this is called the hypotenuse. This is the side, the length of the side that is opposite the 90. Okay, we're going to go into different values of the hypotenuse as we get into angles that are not 90. But for right now, we're going to just leave that as that. Okay, I hope that helps. Again, if you're having questions, if you have any questions, you need me, please let me know. Okay, I hope this helps. I hope you all are doing great, and hang in there. We're almost there.